I'm Anil Kumar. Welcome to my series on integration. In this video, we'll try to understand what happens when we have results which are related to natural logarithms. There are two basic rules which you know. Integral of 1 over x dx is ln x plus c. X has to be greater than 0. And integral of 1 over ax plus b dx is 1 over a ln ax plus b. Ax plus b should be greater than 0. Now, based on this rule, we have three questions here to practice. Question number 1. Differentiate ln 2x plus 5, then evaluate definite integral from 0 to 2 of 1 over 2x plus 5 dx. Question number 2 and 3 are also to evaluate definite integrals, and we need to round their answers to three significant figures. You can always pause the video, answer this question, and then look into my suggestions. Now let's look into the basic concept, right, which is we say reverse differentiation, right? To understand the rule itself. Now, we know that if the function is given to us as y equals 2, let's take that function which is given to ln ax plus b. In that case, we know that dy dx is derivative of ln is 1 over the function, and then we have to multiply by the derivative of inside function. So we get a over ax plus b, correct? Now, integration is antiderivative. What do we mean from this? We really mean that the integral of this right-hand side will be the function itself, right? That is what we mean. So we can write this as integral of a over ax plus b dx should be equal to the function itself, which in our case is ln ax plus b. Right? That is the value of y. Right? So this is equal to y, and y equals to ln ax plus b. Right? So in the rule, what we have done is we have just divided by a on both the sides to get the rule. Perfect. So I hope this concept is absolutely clear. So what we get from here is that the integral of 1 over ax plus b dx will be now equal to, we'll divide by a, so 1 over a ln ax plus b. Does make sense to you? So that is the rule. So the idea here is first to find the derivative, and then from the derivative we kind of do the reverse operation to get our answer. So based on this rule, we'll do question number 1 first. So that is the direct application of this particular rule. Question number 1 is differentiate ln 2x plus 5, then evaluate this particular integral. So let's write this as a function of y. So y equals to ln 2x plus 5, right? So we can say differentiating with respect to x, we get dy dx as equals to 2 over 2x plus 5, correct? So that's what we get. Now we need to find integral of 1 over 2x plus 5. Now that is the reverse operation, right? So 1 over 2 plus 5. So we need to find here integral 0 to 2 of 1 over 2x plus 5, right? This is what we need to find. What do we get here? We get 2 times this, right? So we could say that you could say that this integral is equal to half of, right? So it is half of the function itself. It is equals to half of the function, which is ln 2x plus 5. So from here we get, you get the idea, right? So this itself gives us, you could from here say that y is equal to integral of 2 over 2x plus 5 dx, correct? So if you rearrange, you get this. So this is 2 times, right? So since we now need only 1 time, so you have to divide by this, or you can directly use the rule. But I think you can get the correlation, right? So definitely, we'll have to write c here, right? But when we are doing definite integral, in that case, what we do here is that we can actually, we now know the condition 0 to 2. So we can now find the value of this from 0 to 2. So that is the meaning of definite integral. So we don't need the constant c. Is that clear to you? Okay, so let's do this. So that gives us half of ln. 2 times 2 is 4, 4 plus 5, right? So we get ln 4 plus 5 minus ln 0 and plus 5 is 5, correct? That's what we get. Now we need to use calculator to find the answer. And we'll round this answer to 3 significant places. So we have this as half of ln within brackets 9 minus ln 5. You can say 9 divided by 5 also. Let's calculate the value. So what do we get here is ln 9. So we'll do ln 9 minus ln 5 equals to divide by 2. The answer here is equal to 0.2938, right? So we can approximate this to 3 decimal places, 0.294. So that is how we are going to do this. Now let's take the next question. Now in this case, we have to evaluate the definite integral 5 to 7 of 1 over x minus 4 dx and round to 3 significant figures. You can actually pause the video, answer this question, and then look into my citations. So we need to evaluate definite integral from 5 to 7 of 1 over x minus 4 dx. So using this formula itself, this is 1. So what we get here is that this is equal to ln x minus 4. And the value is from 5 to 7. So that is ln 5 minus 4 minus, 7 minus 4 minus ln 5 minus 4, right? So that is equal to ln 3 minus ln 1. Now ln 1 is 0, so the exact value is ln 3. If you want to find the answer, we have to write to 3 significant figures. So we get here ln 3 is equal to 1.0986. Right, so that is to 4. So we'll round this to 3 significants, 1.099. So that becomes the answer. So I hope the concept is absolutely clear. Now question number 3 is a thinking question. We need to evaluate definite integral from minus 1 to 3 of 6x over 2x plus 3 dx round to 3 significant figures. You can always pause the video and answer this question. So let me rewrite this. It is integral from minus 1 to 3 of 6x over 2x plus 3 dx. Now the formula does not have anything like x term in the numerator. How can you use this formula to find the integral? Well, we could divide the numerator by denominator and write it as sum of 2 fractions. That is what we can do. And here is another way of doing it. So what I will do here is I'll rewrite 6x as 2x plus 3 times something, right? So I could write this as 2x plus 3. To get 6, I need to multiply this by 3, right? So when I do that, what do I get? I get 6x plus 9. Well, 9 is extra, so I'll take away 9. Now it is as good as 6x in the numerator. Correct? So that is how I'm going to write it. Now this really helps to write this as sum of two fractions, sum of two rational numbers. So what we have here, rational functions. So what we have here is 3 times 2x plus 3 over 2x plus 3 minus 9 over 2x plus 3 dx. Correct? Now 2x plus 3 cancel, and so what we get here is from minus 1 to 3 we get 3 over just 1, right? So just 3, right? Minus 9 over 2x plus 3 dx. Is that clear? So what we did was we just cancelled this out. So we are left with a constant 3 here, right? Now the integral will be what? The integral now will be that we have the integral of 3 is 3x, and that of minus 9 is minus, or you could write it separately also. So we could write this as integral this from minus 1 to 3 and take away integral of this using the formula 1 over 2, right? So 1 over a times this. 9 is a constant, so we'll write 9 over 2 ln 2x plus 3 from minus 1 to 3. Is that clear to you? Does make sense? So that is how we are actually going to solve this question, right? Okay. Now let's figure this out. So 3 times 3 is 9. So what we get here is this portion is 9 minus, if I put minus 1 here, then it becomes plus 3, right? Minus this value, which is 9 over 2 ln 3 times 2 is 6 plus 3. So 6 plus 3 is 9 minus ln, well, 9 by 2 is common, right? It's a constant, minus 1. So that gives us minus 2 plus 3 as 1. Is that clear to you? Right. So what we get here is 12 minus 9 over 2 ln 9. Correct? ln 1 is 0. So that is our answer. So let's calculate the exact value. So we have 12 minus, within brackets, 9 divided by 2 is 4.5 times ln 9. And that is equal to 2.1124. Rounding to 3 decimal places, we get 2.112. Is that clear to you? So that is how we are going to write our answer. I hope that makes sense. Feel free to write a comment, share your views, and I hope you have understood how to use this particular rule. And at times, you may have to take care of rational functions, right? Write your function as sum of two rational functions or 3, and then use this particular formula to get your answer. Feel free to write a comment, share your views, and I hope you understand and appreciate it. Thanks for your time and all the best.